You're watching Keystone Science, and in today's episode we're going to turn a microwave into a magnetron gun. Now first let's go over a few things before we get started. Microwaves have a lower energy than light, and so don't be afraid that this project is going to give you cancer or anything like that just from the microwaves. Since the microwaves coming out of the magnetron resonate so well with water molecules, that if the microwaves hit you, they do have a chance to damage your cells, and if they hit your brain, they have a chance to damage that as well. And although you can't see it, I'm actually wearing tinfoil underneath my clothing. This way the microwaves, rather than affecting your cells, would just be absorbed by the tinfoil. Also, another important thing is that due to this, the microwaves can actually make your eyes go blind. And so although we're going to be putting a waveguide on the microwave later to make sure the microwaves only go in one direction, until I do that while I'm testing, it might be a good idea to take the screen of the microwave and use it to cut out some goggles. And although it looks stupid, it might be a good idea to wear a tinfoil hat. So, second off, and as I'll show you later, the microwave that this is emitting will affect electronics. So if you have expensive electronics near it, like a phone or watch, you should probably set them aside so they don't get affected. And in case you're wondering, since the camera I have set up to record this is an electronic device, we're going to build something that'll direct the magnetron rays so they won't be hitting the camera. And second off, just as an extra precaution, I have parts of the camera wrapped in tinfoil to create a Faraday cage. So thus the internal components of the camera will be completely fine. And so here I have an old microwave that we'll be taking apart. First, before we start disassembling this, make sure that your microwave is plugged out. So now I'm going to cut to where I already have removed all the screws holding the frame. Once you have all the screws removed, the outer layer should just peel off. And that should expose all the components that we'll be needing. Now pretty much the main components we're going to be using inside of this is this, the magnetron, the microwave oven transformer, and this capacitor here. Also, while we're taking this all out, I'm going to try to keep these wires in the same connection. That way I can draw a circuit diagram based on what they already have built here. Now I've never seen something like this inside of a microwave before, but mine actually has a circuit diagram on how everything should be wired up. You can see it needs a magnetron, the high voltage capacitor, and the microwave oven transformer to get the magnetron to work. Now I have the magnetron successfully taken out of the microwave, and I attached a wire attaching the frame of the magnetron back to the microwave. So now I have my camera back about 5 meters, and I'm going to leave it and the microphone back here while I go over there and turn it on to see if I can get a light bulb to light up. So now we're going to go ahead and also take out this microwave oven transformer as well as this capacitor. Now although these kind of capacitors have a bleed resistor inside of them that will discharge them as they sit here, it's good practice to go ahead and discharge them to make sure you don't get shocked. And so to do this, you can attach an alligator clip to one of these capacitor terminals and touch it to the other side. And so you should see no spark since this has the bleed resistor inside of it. But if you do have a spark, then it's very good that you did that because that would have shocked you. Okay, so now in designing our waveguide for the magnetron, we need to know a couple of things. First off, the frequency that the magnetron outputs is around 2.45 gigahertz. Now the formula to calculate wavelength is going to equal to the velocity divided by the frequency. And so since we're dealing with light, its velocity is just going to equal to the speed of light, which is about 3 times 10 to the 8th power. And so if we plug this all in, we get 3 times 10 to the 8th divided by 2.45 times 10 to the 9th. And now this calculation gives us approximately 0.1224 meters. And that's going to be equal to about 4.821 inches. And so we know basically a single wavelength, basically this portion of the wave, is going to be equal to about 4.821 inches. And so with this being our magnetron, we have two options. Right from the emission point, we could put a cone that goes up at around 35 degrees. Or in my opinion, the better way is that we could go out one wavelength of distance, and then go up at around the 35 degrees. And so building this frame here out of metal should give us protection from this magnetron, and also the waves will be stronger going out in one direction here. Okay, so now to make that little box at the beginning of the waveguide before I hit the cones, I drew this box onto the metal frame of the microwave that we had previously removed. When I measured the side lengths of my magnetron, it was 3 inches by 3 inches. And so from this point to this point, it's 12 inches long. And it goes down 4.82 inches. And so anyways, now I'm just going to cut along these black lines with these tin snips. Okay, so now with that piece cut out, I have lines drawn every 3 inches and I'll be able to fold it. Also note, I have about 1/2 of an inch here so I'll be able to fold it over. In order to get it nicely folded, I'm just going to place it here on the edge of the table, then push it down. Okay, so now with that piece folded over, you can see that we can just lift this up on over, and it should stay in place. And so going back to the magnetron, you can see how the box we made fits nicely on top of it. Okay, so now out of cardboard, I cut these two side templates out that I'm going to be using. If you want to replicate what I did, here are the dimensions for each of them. And if your magnetron is a different size, then you could times all the side lengths by the different size ratio. I'm now going to take these and try to fit them on from the cover of the microwave. But anyways, I'll be right back with you guys when these are cut out in metal. Okay, now I have the metal all cut out and it roughly put together. So anyways, now I'm going to take this metal enclosure and I'm going to go put some epoxy on it. But for the epoxy to set in fully, it's going to take about 8 hours, so let's go to that now. Okay, the epoxy finished setting, and after it did, I applied these strips of aluminum tape. Not only will these strips of aluminum tape make it so no microwaves can get out, but also they make it quite a bit more strong, as the epoxy alone is pretty brittle. Now our plan was to have this small box here and then put the top on like this. However, I figured it would be much easier to attach this to the magnetron if I used this. When we first opened up the microwave, this is what the magnetron was sitting in, and so I took my angle grinder and somewhat crudely cut out around it so we could pull it out. Now I know looking at this you'd expect that the microwaves are being emitted out of this top part, but actually it's being emitted radially from this pink beryllium oxide. Now as you do this, be very careful not to shatter this pink part here, because this pink part might be made out of beryllium oxide, and if you shatter that and breathe it in, it'll be very bad for you. And I assume this angle is actually 35 degrees, and so that should mesh together quite nicely with the waveguide I have made. And so now I'm going to go ahead and attach this back onto the magnetron and screw it into place. Now next I'm going to be putting on this top part that I made. Now I would probably be using epoxy, but that's going to take too long to set. And so for now I'm just going to try to hot glue this on, although I know that that's going to probably fall off very easily. And now we have everything to direct the microwaves completely assembled. Now I'm going to attach the rest of the circuit onto this board. Now before we drill on the holes, there are two things we need to do. First, lightly sand the outside of the microwave oven transformer. We need to do this because there's an epoxy coating on the outside of the transformer. And by sanding it, it'll allow us to make a better connection when we connect it to ground. Now this that I'm going to put behind the transformer is optional. Basically, this is called a noise filter, and its main purpose is to produce a nicer sinusoidal wave out of the voltage going into it. And so this isn't necessary, but since my microwave had one of these, I'm going to be connecting it into it. And so first I'm going to drill on some pilot holes for the microwave oven transformer. Anyways, now I'm going to slip these two ground terminals onto this screw. And now with that done, I can screw it into place on the body of the transformer. And then on the other end of the transformer, I'm going to attach this wire with this tab onto it. For the capacitor that was inside of the microwave, there's normally this little casing that secures it onto the frame. And so now we're going to be using this little casing to secure it onto this wood. Since the magnetron is going to get quite hot while it's operating, I'm going to be using this fan to cool it down. And so for that, with this noise filter, I'm just going to solder it to the output wires in parallel. If you don't have this noise filter, you can just wire it in parallel with the mains power. Okay, and now with the fan screwed into place, all that's left should be attaching the magnetron. And so I'm going to use these small holes down here to secure it onto the board. And now all that's left for us to do is connect everything up. And so now we need to get the ground connection onto the magnetron. So I'm going to connect the free end of the diode onto the body of the magnetron. And then I'm also going to connect this wire, which comes from the body of the microwave oven transformer, onto the body of the magnetron. And lastly, we can connect these terminals into the microwave transformer, and then that connected back up to our noise filter. And now our magnetron gun should be complete. I added these two handles on the bottom just by cutting wood and screwing it onto the top here. Now something you guys really need to know is about the safety of this microwave oven transformer. That little transformer there outputs over 2,000 volts, and along with that it can output a very high current. In other words, if you touch the output of that transformer, you're practically going to die. And since the other end of the transformer is connected to ground, it's going to probably arc through you. So never under any circumstances touch any part of the circuit while it's turned on. Even on the low voltage side, it's still 120 volt mains, and that'll be very painful. And so with that said, I'll say to you guys, do not try this because it's very dangerous. Anyways, with that all said, let's go ahead and try this out on some things. Now it's actually been pretty hard to find an area to test this out at. In fact, the only real safe spot I can do this at is at that Tesla coil back there. Whenever I point this in the general direction of a plug, the breaker instantly flips. So let's go ahead and try turning this on and lighting up this fluorescent bulb I have back here. As you can see, when I shine the gun at the bulb, it instantly lights up. And by the way, that sound you can hear is when I point it towards that plug. Now the microwaves shouldn't be interfering with the microphone since it is directional, but they might be. So as you can see, I can get quite a range on this. Right now I'm about 2 meters away from that light bulb, and it's still lighting up very well. Now in case you're wondering why this microwave gun was able to light up the fluorescent bulbs, basically what's happening is the concentration of microwaves is ionizing the mercury inside the bulb. Basically it raises the atoms inside of it up to a higher energy level, and then when the atoms lower back down to the regular energy level, they emit UV light. Then the outside of the fluorescent bulb is coated in material that lights up when the UV light hits it, so thus it sort of changes the UV light into visible light. Okay, so now to show you what this guy does to electronics, I'm going to turn it on and point it at this microwave oven timer we made in a previous episode. You'll only see it for a second because when it does, it'll instantly flip the breaker. And since this microwave gun is connected up to the same system that breaker is, it should shut it off very quickly. So let's go ahead and give it a try. But it took a few seconds to shut it off just because it was practically warming up to start sending the microwaves. So now you know how you can turn an old microwave oven into a microwave directional gun. Thank you all so much for watching the video. If you enjoyed it, I'd really appreciate it if you'd leave a thumbs up, as it really helps the channel quite a bit. And if you'd like to see my weekly science videos, go ahead and hit the subscribe buttons that will show up in your subscription newsfeed. Since this is a dangerous project, if you don't know what you're doing, please do not try it at home. So with that in mind, please remember to be safe, and have a wonderful day. You're watching Keystone Science, and in today's episode we're going to show you how you can transmit data through light.